Hey everyone, Chang here and welcome to my channel. For today's video, we're going to focus on word problems. Yes, not my personal favorite. And from my teaching experience, not a personal favorite with a lot of other students. But here's the thing. The skill of working with word problems is actually quite important. One of the more important skills you gain when you're studying math. The reason for that is that even though you could be very good at calculations, very good at equations and formulas, unless you can change a real life situation into an actual formula, into an actual calculation, it's not all that useful. Yes, I understand that word problem is not exactly representative of real life situations, but that skill nonetheless is actually very important. Now, when I was looking for ways to either present it, to find shortcuts on very quickly being good at word problems, I found some, but I feel like they're always oddly very specific, only for a certain type of word problem. So it focuses on the underlying structure instead of actually just building a skill to understand word problems in general, right? They focus on things like if you ever see sum, that means adding. If you see difference, it means subtracting. If you see, quotient or product, they focus on little vocabularies like that. And that's not to dismiss the importance of it. I feel like to truly understand word problems, you have to, have some level of competency in terms of understanding the actual question, the actual, words. So we're going to focus on that. And then from then, hopefully, just trying to figure out patterns, we're able to come up with formulas, what to do with the actual problems, and in the end, solve it. So let's begin. So for our first problem, we have this word problem right here. Now, when I was thinking about how to actually approach word problems or what to do, I always ask myself, what exactly am I doing with basically the variables, or at least the sort of subjects that the word problem is about? So let's just look at this problem. Bob is 3 years older than twice Jane's age. If Jane is 15, how old is Bob? So I have two subjects that I'm working on, Bob and Jane. So let's just put Jane right here, ladies first, right? And Bob. Okay, and here it gives us Jane is 15, how old is Bob? Okay, let's just ignore that for a second. How is this problem structured, or what is the underlying, you could say, equation under this? Well, we got to ask ourselves what we're doing. If I say Jane is 1 year old, how would I find Bob's age? We know that it's going to be twice Jane's age and 3 years older. So we're going to get Jane's age. In this case, I chose 1. And if I'm going to do twice it, I'm going to multiply it by 2, right? So that's 2. And then it's 3 years older, so I'm going to add 3. Well, in that case, 1 times 2 is 2, plus 3 is going to be 5. Okay, what if I didn't choose 1? What if I chose, for example, 4, right? How would I find Bob's age? Well, same thing. Well, in this case, we're going to twice this, 4 times 2, which is going to be 8. It's going to be 3 years older. So it's going to be times 2, 8, which is, and plus 3, which is going to be 11. And then we continue on. I can choose something like, for example, 16, right? Once again, doesn't change. What I'm going to do is going to be twice it, which is going to be 32, plus 3, which is going to be 35, and so on and so forth. Well, if that's the case, what am I doing every time? I'm getting this number, I'm twicing it, so I'm basically multiplying it by 2, and then I'm adding 3. So that gives us this underlying structure. We know that every time we get Jane's age, we're going to multiply by 2, so let's just make it obvious right here with the 2 in front. And then I'm going to add 3. That gives me Bob's age. And just like that, by asking myself, what am I doing every time I just decide to choose a number in relation to one of the subject, how do I get the other, you could say, number for the other subject? Well, in this case, we figured out our equation. Bob's age is equal twice, or 2 times J, plus 3. Well, if that's the case, I can actually plug this in now. I can plug in J for 15 and then solve for B, which is Bob's age, and that will actually tell us the answer for this problem. Now, here's a second question, right? The sum of 5 consecutive integers is 80. What is the largest integer? Now, this is not like 1 or 2 subjects. There's actually 5 subjects, right? 5 consecutive integers. Luckily, we know consecutive means just one right next to each other. And integers, hopefully we remember, is basically positive or negative whole numbers and 0. Now, When it says the sum of 5 consecutive integers, what we're looking at 5 consecutive integers, we're adding them together, and it's going to be 80. Then we want to figure out what the largest one is. Now, of course, we can always brute force it like crazy. We can do 1, 2, 3, 4, 5. It only makes sense. You don't want to add 0 because it really doesn't do much. And you can add negative, but most likely it's not going to be the case, right? 1, 2, 3, 4, 5. We added together what? This is going to be total 6, plus 4 is going to be 10, plus 5 is going to be 15. Okay, cool. And then we can go on from there. Like instead of 1, let's just start with 2, and then 3, 4, 5, 6. And what is that? That's going to be, this is 5 plus another 5, that's 10. 4 plus 6 is another 10, so this is going to be 20. And then we can continue on until hopefully we get to ones that add up to 80. Now, let's just say we don't want to do that. We want to actually figure out some form of equation to solve this problem. Well, notice this though. Even no matter what kind of consecutive number, let's just say, for example, I decide to go crazy and I just go 8, 9, 10, 11, 12, right? That's 5 consecutive number. I'm not going to add them, but you can see it's 5 consecutive number. How do I know the consecutive number? I start off with one number. Then the next one's just going to be the previous one, add 1. The next one to that is just the previous one, add 1. The next one to that is again, previous one, add 1, and then so on and so forth. So I always have a starting number. Let's just say starting number. All right, whatever number I choose, I'm always having a starting number. And the next one is the same starting number plus 1. Starting number, and then now we're going to add 1 to it. Right? That's our next one. So whatever our starting number, the next one's going to be add 1. Well, guess what? The next one is just going to be the previous one plus 1. So it's going to be this second one right here. I'm going to do it starting number plus 1, which was the one previous, plus another 1. All right? And I keep going. Well, the next one from that on is going to be the previous one plus another 1. So this is going to be the previous one now. It's going to be starting number plus 1 plus 1, and then now I'm going to add another 1. Okay, how many numbers do I have? 1, 2, 3, 4. Remember, we want 5 consecutive numbers. So we need to do it again. This is now going to be our previous one, right? And so our next one is going to be starting number plus 1 plus 1 plus 1, and then, well, since it's the next one, it has to add another 1. And just like that, that's exactly what I'm doing every time I'm trying to find the 5 consecutive numbers, right? Well, if that's the case, there it is. Starting number plus 1, starting number plus 1 plus 1, and then so on and so forth. Rather than having to write starting number, which I did, waste of ink. But what we can do is we can actually make this a variable. And let's just use the most common variable ever, x. So it's going to be x. This is going to be starting number. It's going to be x plus 1. Okay, the next one, starting number plus 1 plus 1. Well, plus 1 is technically plus 2, so it's just going to be x plus 2. Well, I mean, this one you can guess. It's going to be x plus 3. This one is x plus 4. And there it is. All of a sudden, our 5 consecutive integers can start from x, x plus 1, x plus 2, x plus 3, x plus 4. And, well, we're trying to find the sum of it, so we add them all together. X plus x plus x plus x plus x. That's what? 5x. I'm just write it right here. 5x plus, and then 1 plus 2 plus 3 plus 4. That's what? 10? 10. And just like that, we want it equal 80. We have an equation to work with. And then from then on, we can actually try to figure out what the largest integer is. And just a little hint, well, guess what? The largest integer is probably going to be the one that add 4. Figure out what x is, add 4. There it is. And that's how you would solve a problem like this. Alright, let's look at this problem. The height of a rectangle is twice the size of its length. If the perimeter is 120 centimeters, what is the area? Question mark right here. Alright, now, here's the thing. Well, first and foremost, we're working with a rectangle. Let's draw a rectangle. At least just so we can visualize it. Right, we have our length right here. And from definition of rectangle, this is also your length. And you have your height right here. And you have your height right here. Cool. We at least have that. Right, we have our length and we have our height. Now, it tells you a relation, which we're going to take into consideration. If the perimeter is 120 centimeters, what is the area? Well, first and foremost, we're working with perimeters. So for perimeters, we got to remember, for finding the perimeter of a rectangle, we're just basically adding all four sides. So we have our length, length, height, height. Okay. If, for example, let's just say I focus on one subject, I'm just choose length. Let's just put length right here. And I choose it to be 1. How would I find the perimeter? Well, I know that this is going to be length. This is going to be length, so it's going to be 1, 1. And the height from here, we know that's twice the size of its length. So this is, instead of 1, it's twice the size. It's going to be 2, 2, 2. So it's going to be 1 plus 1 plus 2 plus 2, right? So what is that? 2 plus 2 is 4 plus another 1, 1. That's 6, right? So that means the perimeter is 6. Okay. Now, if I chose the length 2, what am I doing again? 2, 2. The height itself is twice, so this is going to be 4, 4. And I'm adding them all together. 2 plus 2 is going to be 4, right? And then this is 4 plus 4. That's going to be 8. Add them all together is going to be 4 plus 8 is 8, like 12. So here we are. Now, the numbers itself is great. But what am I doing? That's the question we always have to ask ourselves. Well, first and foremost, I figure out what the length are. I add it twice, so it's going to be twice the length, right? It's going to be 2 times the length because I'm adding those two. And I'm adding 2 of the heights as well. That's all, the perimeter. But I'm not focusing on the height, right? Every time I am focusing on the length, the height I just found from the equation itself or from the problem itself. And what I do is I just multiply it by 2, multiply the length by 2. So in that case, instead of 2 times height, the height itself is actually 2 of the length. So rather than height right here, it's just going to be basically 2 times 2 length, which gives us 4 length, right? And in that case, that means the perimeter, I'm just right here because I'm sort of unorganized and I'm running out of room. Perimeter is now just 2 length plus 2 times 2 length. So that's 4 length, total 6 length is the perimeter, right? So we can just do P equals 6L. And from that on, we can find basically, where is it? Here. We know that it's going to be 120 centimeters and we can find L. Well, from L, we can find H because we know the relation. And from that, we can find the area because if you guys can remember, the area is just basically length times height. And just like that, always asking the question, what the heck am I doing from one to the other will actually gives us our better understanding of the relationship and then start formulating the equation from there. So thank you for watching this video on strategies of dealing with word problems. Is there a quick way? Is there an easy way? No, not really, right? It's based on experience, it's based on your word comprehension, your vocabulary comprehension, but hopefully every time you encounter problems like this one or any of them, right? Pick the subjects that you're working with, in this case, length and perimeter. The other ones were what, the 5 consecutive integers or Bob and Jane, and then ask yourself, given one, if I put in some random number, can I find the other? If I can find the other, what am I doing exactly to find the other? And is there a pattern? If I change the number, am I doing exactly the same thing? If I am, there is something there. There is a potential equation, a potential structure of the problem that I can actually work with. And from then on, I can start piecing things together and hopefully find a way to actually solve the problem. All right. Thank you again. See you in the next video.